This is a demo of Schedule Solver. Schedule Solver is a solver engine for the automatic optimized assignment of shifts to employees. It is designed to integrate with existing workforce management software via an API. It is developed and licensed by Staff Roster Solutions, a university spin-out company with over 15 years of experience in researching and developing algorithms for staff scheduling problems. The graphical user interface shown here is an application used to demonstrate and test our solvers. It is freely available for download on our website. Note that although this is a desktop application, the solver itself is a .NET library, which also runs on Linux and macOS, and also integrates with web apps and software as a service models. It now also runs within a browser via WebAssembly, a demonstration of which is available on our website. Schedule Solver is used for assigning shifts with predefined start and end times. For problems where the start times and end times need to be optimized, and optionally, also the activities within the shifts, such as breaks, then our product called Shift Solver is a better option. The user interface shows the employees to be scheduled, in this case labeled from A to V, the planning horizon across the top. In this example, we are planning a 30-day period, and the shifts assigned. All these are user-defined inputs. Problems could range in size from a few employees up to thousands of employees, and with planning horizons of a few days up to a whole year or longer. We can also see more information on the problem in these tabs. Here we have the staff available with their skills and their contracts. In this example, there are some who work full-time, some who have part-time contracts, and some who work only night shifts. Here we can see the tasks or shifts to be assigned. They have start and end times. They may also have required skills. They may have an associated shift type, which is used for defining other constraints. For example, constraints related to night shifts, such as a minimum rest time or allowable shift rotations. They also have weights associated to reflect their relative importance of assigning or not assigning these shifts in the solution. The weights are used to ensure the solution satisfies the cover requirements while optimizing over and under coverage. As well as the cover requirements, we also have constraints on each person's individual schedules. Again, these are customizable, and we can see some examples in this panel. Most scheduling problems have constraints on the minimum and maximum working hours. They may be per week, or 4 weeks, or any defined period. This person must work a maximum of 168 hours this month. There are typically constraints on the shift and working day patterns. For example, this person must not work more than 5 consecutive days, or less than 2 consecutive days. They must have at least 2 consecutive days rest. There are also constraints related to shift rotations, night shifts, and weekend work. These constraints are also user-defined and customizable. Like the shift constraints, these constraints also have weights to reflect their relative importance. The higher the weight, the more important it is to satisfy this constraint in the solution. It is also possible to define more complex constraints, such as if-then rules. We call these expression constraints. We have an example here which says, if person A has more than 4 night shifts, then they must not work more than 36 hours per week. Once the problem inputs have been defined, then it is ready to be solved. To distinguish a good solution from a bad solution, the solver uses a penalty function value. This is a number which represents how many constraints are satisfied in a solution and their relative importance. A penalty of 0 means that all constraints are satisfied. However, as constraints typically conflict with each other, there normally is not a solution with all constraints satisfied. Instead, the solver must find the solution with the lowest possible penalty. This value is shown here and can be seen to change as shifts are reassigned to different employees, or unassigned as highlighted. To demonstrate the solver, we'll first unassign all shifts so we have an empty solution. Note that an empty solution has a high penalty value because many constraints are not satisfied. We then start the solver. As the solver is running, we can see that the penalty of the best found solution so far is gradually reducing, meaning it is finding better and better solutions as the search progresses. The solver is finished. It has found a solution with all tasks assigned, 0 hard constraint violations, and a penalty of 0. On this desktop machine, it found just over 15 million feasible solutions in approximately 8 seconds at a rate of about 1.7 million feasible solutions per second. We can see that all the shifts have now been assigned, and the total penalty is 0. This demo has gone through some of the basic modelling features of Schedule Solver. The application is freely available for download on Staff Roster Solutions' website. It contains more examples and can be used for testing and evaluation purposes. More information on the full modelling options and integration features are available on Staff Roster Solutions' website.